Okay, let's get started. First of all, I'd like to thank everyone for taking the time to attend Martin Instruments' webinar on processing V10 photo stations using Trumbull Business Center software. My name is Mike Minnick. I will be the presenter today. To start with, I'd like to go over the agenda of what we're going to cover. So we will cover the hardware and software used to generate this presentation, which would include the V10 imaging rover, the R10 GNSS receiver, and the Trumbull Business Center software. We'll then move on to the Trumbull Business Center software, where we'll cover importing the JXL file with images. Then after importing those files, we will perform a network adjustment of the photo stations. We'll use the automatic adjustment option. Once we have the adjustment computed, we will review the results and review the automatic tie points that were created during the network adjustment. After that, we'll move on to measuring photogrammetry points using the station view. We'll review the photogrammetry points using the photo point spreadsheet, and we will also review the quality of the points using the point derivation report. Finally, we will go over an additional feature that enables you to create panoramic photos that you can view and share using Google Earth. And finally, we will review and kind of summarize what we went over today, and we'll wrap up with some questions and answers. So with that, let's move on to Trumbull Business Center. So what I'm going to do here is go ahead and start a new project. I'm going to use a US survey foot template and create that project. I'm then going to import in my data set, which is this job XML file, which was created off a Trumbull tablet, which is the recommended controller to use with the V10. Because of the file sizes, you can at current time use the GSE3. So I'm going to import that file in. It does have a geoid conflict message here, so I'm going to correct that with the geoid 12A geoid model. I'm going to hit no to the import summary. And here's our data set. So this data set was collected using VRS. So we have some pretty long RTK vectors coming into our project site. So you can see there's some RTK shots and there's 4 photo stations. The photo stations are represented by the icon of the V10 itself. What I'm going to do is turn off the RTK vectors just to kind of hide some of the clutter. I'm going to do that using my View Filter Manager. I'm going to pull that up over here, and I'm just simply going to toggle off the RTK vectors. Now, while I'm in this View Filter Manager, I am going to toggle on the feature codes, so I can tell what the points are that I'm looking at in case I want to check them after the adjustment. With that, I'm going to go directly into the Photogrammetry module. I am going to go straight into Adjust Photo Stations. And then I'm going to set up my adjustment to the method I would prefer. If I pull down this menu, there's 4 different adjustment methods: raw center values, azimuth only, full orientation, or standard resection. As you pick on these different options, it will give you a brief description of what is entailed in that network adjustment. The full adjustment, what it does is it adjusts for the station compass and tilt values, meaning the station and compass tilt values in the V10. It holds the values generated from either the R10 or a robotic total station. It does require a minimum of 6 common tie points. Those tie points can be created using the automatic adjustment. So with that, I'm going to toggle on to the automatic tab, and I'm going to go ahead and say adjust with automatic tie points. So what's going on here is it will run through its itinerations to hopefully solve the solution of the 4 photo stations, creating the network adjustment with the different pixels, images, everything. The automatic tie points will tie everything together. So it runs through an automatic tie point adjustment, feature extraction, and then 5 steps of blunder detection. With the 4 photo stations I have here, if you have an average grade PC processor, it'll take about 3 to 3.5 minutes. If you have slower machines, it could take 5 or 6 minutes. So I give you an idea with 4 photo stations what to expect. While this is cranking along here, I'm going to keep an eye on the progress down here and kind of go over the data sheets. So the V10 is a fairly new product from Trumbull. This device can be used as a standalone camera, or it can also be used in conjunction with the R10 GNSS, or you can mount a 360 prism on top to use it with an S6 or VX robotic total station. The V10 has 12 5-megapixel cameras mounted around it. There's 7 cameras mounted arrayed out, and there's 5 cameras arrayed down. There is a blind spot on the back for the observer, so you don't continuously take pictures of your face. Some of the features of this is, it has an onboard power system through a specialized power rod. It uses the same batteries as the R10 to keep things fairly simple. It can withstand a 2-meter pole drop test to pavement. When you use this in the field, basically you can take a shot with the R10 and say, I do want to collect panoramic images. It captures a shot from all 12 cameras. Takes about 3 to 5 seconds to capture 60 megapixels of visual images. So with the V10, we're also using the R10. So this is the latest GPS receiver from Trumbull. As I mentioned, it has the same battery system as the V10, so it's a pretty nice fit. The R10 can mount directly on top of the V10 using this quick release system. That allows you to take a GPS reading, as I mentioned before, and immediately follow it with a photo station. The R10 does have some new advanced features. You can see here it is capable of tracking the Trumbull Centerpoint RTX satellite correction stream. It has the new HD GNSS processing engine, XL technology, and Trumbull 360 tracking. It also has a tilt sensor in it, which helps in the field because you can see the level bubble on the screen. We've already covered the V10. Let's take a look at the TVC software. What I have here is the 4 current levels of TVC, I guess you could say. There's base, complete, advanced, and now there'll be an aerial photogrammetry module coming out to deal with drone data sets. I can see here that my automatic tie point adjustment is complete because this message came up, so I will pop back into TVC, and I can see the results here. Finished 4 adjusted stations, 0 failed stations, 267 automatic tie points created. I'm going to go ahead and apply that adjustment. The project is recomputed, and I get some results over here. I'm going to close out this message. What you see here are different statistical indicators of how well the data set was collected in the field, and also the positioning of the photo stations relative to each other. So you have station geometry, and each one obviously has a ranking out of 10. Observation accuracy wasn't that good on this data set. We did have good tie point distribution, pretty good geometry, not so good on redundancy because we only had 4 photo stations. If you want to actually be able to share this report, you notice up here at the top you have under the adjust photo station you have the ability to pull up the terrestrial bundle adjustment report. This is really similar to the network adjustment report when you're working with GPS data sets. Obviously up here you can export it, you can save it in different formats, you can print it, whatever you need to do. Looking down through this report, again I see the scoring. Again, this is something you share to prove the accuracy of your data set. You see different statistical indicators here. One that I like to kind of look at is right here, this tie point back projections. Kind of gives you an idea at a distance of 10 meters, so about 30 feet, how you're looking on residual. Standard deviation constrained about 300ths, maximum, meaning the maximum error pretty much around 1400. So just giving you an idea of the results of your network adjustment. I'm going to go ahead and close out of that and close out of that window and get back to my plan. So what happened there in the background is some automatic tie points were created. Let me give you an idea of what I'm talking about there. I'm going to simply click on this photo station 4 and pull it up, or select it, I'm sorry, and say new station view. So now it's as if we're standing on station 4, and you can kind of see what's around you in a 360-degree view. You can notice here there is a dead spot. This is where the 2 cameras are not mounted. You can see my head here looking really good. and kind of get an idea of what you're looking at project-wise. What I'm going to do is split my screen. To do that, I'm going to right-click here and say New Vertical Chapter. What that does, it allows me to kind of see the different zooms. Notice when I zoom in and out, you can see this cone of view increasing or decreasing as I zoom in or out. So you can kind of tell which way you're looking and how zoomed in you are. Additionally, you can see here's Photo Station 2 over there. There's Photo Station 1. Here's some targets I put out just in case the automatic tie point adjustment fails. I've got some checkerboard targets out there that I can do some manual ties to, just kind of as a backup. But our area of interest for this particular project was this water valve. We wanted to kind of measure a few points on it and collect some features that maybe the crew didn't get in the field. What I'm going to do is pull up a second view here. I'm going to pick on Photo Station 1 and also say New Station View, and you'll notice it pops up here, so I can easily toggle back and forth between Station View on point number 4 or point number 1. So what I usually recommend here before we get into, before I get ahead of myself, let's go turn on, using our filter manager, the automatic tie points, just so you can get an idea of what was created there. So this box by default is checked because it's a little bit overwhelming with the vectors and points, but I'm going to go toggle it on, and you can see in both panes what we're talking about here. So what you're seeing here are the vectors from each photo station tied out to automatic tie points the software detected. You can see what the software detected. Sometimes it's fairly interesting. So in this case, it picked some features on this train here, which was stationary at the time. It's pretty amazing the way it's basically recognizing pixels here. Sometimes you could use these points for your data set, but otherwise they're again used to tie together your photo station network so that it can be adjusted. So with that being said, let's get back to the process of creating some photo stations. So what I'm going to do is I'm going to attempt to create a point on top of this valve, and I might try and create a point from a different photo station. So you can see right now I'm in station view 1, and this is my field of view. So you can, just so you don't get lost in a large data set, I'll toggle over to 4 and zoom in kind of on the same feature, and you can see here my area view cones are intersecting. So that I have them both pointed in the direction I want to create a point on this valve stem. So with that, I'm going to go straight into creating that point. So I'm going to say here simply measure photo point, and I get another screen popped up. So I'm going to kind of slide this over a little bit so I have a little bit more room to work with. So I simply give it a point number I want. I'm going to say point number 1000, and feature code I'm going to say is VLV. And this is a feature in TBC here that you can, I recommend leaving it checked. Basically what happens is we're going to pick on this valve stem, and if you have this checked, the software will try to match that pixel from your other photo station, in this case the other 3 photo stations, see if they can find a match automatically. If it cannot, you'll need to pick it from a second photo station. So by simply putting the cursor down in here and dragging my mouse over, you see I get a crosshair. So I'll zoom in and pick on the top of the bolt the best I can, and it goes through its process of computing. I am seeing a point there. Notice that point number 1000. So I'll say recompute the data set, and I'll come up here to my project explorer tree and see if it actually did in fact create that point. I don't think it did. It did not. So the point number 1000 is in the data set, but because it has no coordinates here, I can tell it was not successfully created from one station view. So no big deal. I will just go back to my second station view, station 1, and zoom in on that same point. Make sure my point ID is still 1000. And I will put my cursor here and pick and let it run through its computation, and I will say compute, and I have a point now. So while that's going on, you can see here in the cones, you see my rays bisecting. Wherever those rays bisect, that's where the point will be created. Now I did end up with a error flag on that, so let's take a look at it. Point number 1000, large vertical residual, resulted in poor solution. we'll cover that here in a minute. Let's go ahead and create a second point so that we can have a couple different points to look at in the photo point spreadsheet. Okay, so I'm going to change over to point photo station 2, and I'm going to zoom out. Let's look across the street here. Since this train was stationary, let's kind of zoom in on maybe something here just to see how this automatic tie point creation works using just a single selection here. Instead of 4, I'm going to go ahead and use 3 since it's kind of on the same side here. So I'm going to toggle over to 3, wait for it to populate here, zoom around to the same view, zoom in there. Actually, made a mistake there. Let's put it back on 2. So now I have 2 and 3 how I want. And let me zoom that back over there. All right. So again, we can kind of go back over here and zoom out a hair, and you can see they're pointing in the same direction. It's not quite bisecting because it's kind of a long observation, the distance from the photo station to the actual train itself. But nevertheless, let's go ahead and try and pick that point. So I'm just going to randomly start off on station 2. I'm going to give it a new point ID, 1001. I'm going to call it just train. I'm going to leave this box checked. I'm going to put my cursor in the pixel picker box, and I'm going to look for the corner of the 7 here. So I'm going to say that's about it right there and pick it. And it looks like it did compute it. The way I can tell just by looking at it graphically compared to the previous point I tried to select is notice these additional rays that were computed. I can look at them here in this station view, and I can also see them over here in my plan view. So it's looking like it did create that point, so I'm going to go ahead and compute that and close out of there. So now I have that point created on the train, and I also have the valve point created. So once you have points that you've created, photogrammetry points that you've created off the photos, you might want to have a way to check the quality of those points. So an easy way to do that is use the photo point spreadsheet. That's also under this photogrammetry module. What we have here are the results. So you can see this isn't always, to me, the easiest way to understand this. In this case, I have point number 1000. I have observations for point number 4 and 1, the distances, the vertical distances, and the horizontal and vertical residuals. For 1001, I have the same information, but the horizontal and vertical residuals, since they're in degrees, minutes, and seconds, don't always mean a lot to me. So you can use this report to kind of check your quality, or additionally, what I like to do is make this a little bit bigger here and pick on point number 1000 and say also pick on point 1001, and then simply right click and say give me a point derivation report for those points. This point derivation report breaks down things in a little bit easier to understand language. So here's point number 1000, here's the resultant coordinates, and here's how this point was created. So observations from 4 and 1, we have a horizontal distance residual of about 200ths and 100, and we have a vertical distance of 500ths by 400. So because it's broken down in an actual unit I understand, US survey feet, it's easier for me to look at the quality. And in this case, photogrammetry is similar in some aspects of GPS, that normally your horizontal residuals are pretty tight. Vertical is usually maybe 2 to 3 times, has 2 to 3 times more error. Okay, so that's a little bit of covering the photo station or photogrammetry point generation. Another great feature of this photogrammetry module in TVC is the ability to process panoramic images that you can then share to your clients or your colleagues. So I'm going to go ahead and just create these files for just photo stations 1 and 2, because it does take a second or two here to create these. While I was processing, I'll explain what's going on. So I get my little progress bars up here. So each one of these represents something else. I have balanced exposure for all 12 images for a more uniform look from each station view. And I also have blend the edges of the adjoining images so they're less noticeable. Just kind of smoothing things over. And then additionally, it's going to create a panorama file that I can then view as a flat file, just to kind of see the image from a different perspective. So while this is cranking out, just kind of going over it again, we imported in the job XML file. It came right in. The photos automatically are imported into the job XML as long as they're on the same directory and on the same directory of your computer. We performed an automatic fully constrained adjustment, which, as I mentioned, I had 4 photo stations. It took probably about 3 minutes on my computer, but it might take up to 5 or 6 minutes with a slower processor. We reviewed the results, pulled up the Blender network adjustment report, and then we went straight into measuring photo stations and covered how to look at the quality of the photo stations that are created. And again, that depends greatly on the geometry and the spacing of your photo stations we collected these images from. We also looked at the point derivation report as another way to check the quality of the points that are created. So with that being said, now I can see that my photo files were successfully created. So I'm going to close out of here. And then I'm going to go ahead and save this project. I haven't saved it so far. I'm just going to save here and call it V10 Seminar. And then save. That way I can navigate easily on my computer to the directory where these new photos were created. So I'm going to minimize that and go here to my documents, my Trumbull Business Center, and V10 Seminar. And you can see here, it created a folder called GE Panorama, Google Earth Panorama. So I could just have a JPEG. Here's the JPEG flat file from Station View 1. But what I'm more interested in is the KMZ file. So I'm going to select on both these KMZ files and simply drag them into Google Earth. When I do that, it zooms me into my project. So what we're going to see here is we are able to actually enter into the 360-degree sphere we created with the V10 imaging rover. That allows us to pan around and get a street view of the project. Now you might be saying to yourself, hey, this is something I can already do in Google Earth without the V10, and that is true if it is in a residential area that Google has driven by to collect this imagery. But when you talk about remote locations where oftentimes surveyors go to conduct projects, there's not going to be any type of 360-degree image files like this from Street View. I can also exit that photo. It gives me a bird's eye view again, kind of a range of view. And if I want to enter back into 2, I simply click into 2, and now I enter the sphere photo station 2. So again, a pretty neat little feature here. Allows you to share maybe what's on the ground with your clients or with your supervisors. But again, if you're out there on the job site with a V10 and an R10, what it allows you to do is collect the data in the field and then collect the images as just in case, or to limit the amount of time that you're in the field. The remaining points can then be created in the office. So with that, that's pretty much it. I already kind of went through a brief summary, and then the last part here was really the Google Earth panoramic image creation, which is simply a couple button clicks here, process panoramas, and simply check the boxes you want to use, and then bring them into Google Earth. So with that, I will end this presentation and move on to the question and answer.